So hi everybody and welcome to video number 9 in the solutions series. So in this solution we'll discuss about the applications of Henry's law. So what is Henry's law? It tells you that for a gas in liquid, if your 2 represents solute, so again I'm reiterating, 2 is represents solute and 1 represents solvent. So it means that the amount fraction of solute in a gas is directly proportional to is equal to some Henry's constant multiplied by the pressure P2 above the liquid. So this is your Henry's law. Now this equation is something similar to y is equal to mx plus c, and if you plot a graph, what you end up getting is so if this is your pressure P2 and your x2, what you get is a line whose slope is given by kh. Okay, now because this equation x2 is equal to kh into P2, now as kh increases for a given pressure, okay, let me start with the first application. For a given pressure, as kh increases, x2 decreases, right? For if this is constant, if kh increases, x2 decreases. So and again kh is temperature dependent. Okay, this has been studied experimentally. For example, kh of oxygen at 293 Kelvin is 34.86 kilobar. Okay, and kh of oxygen at 303 is 46.82 kilobar. Now see here, what is happening? kh is increasing at a higher temperature. If kh increases, what will happen? Your x2 decreases, which means the amount of oxygen that is dissolved in a solvent is decreasing. Okay, so that is why there is something called as dissolved oxygen. Aquatic life depends on dissolved oxygen, which is oxygen, a gas that is dissolved in water. Okay, so this is your solution. Okay, so now because at higher temperatures your kh is increases and therefore x2, the amount of gas in liquid, that is water, decreases, your aquatic species are more comfortable in cold water rather than in warm water. Okay, that is why if you have seen some of the great sardine migration, or why in and again if you have seen few videos, you would know that salmons can jump against current and up to 3 meters to migrate. So because they, of course the needs are very different, but yes, fishes do migrate and they are in search of a cold water rather than warm water. The next application is in your soft drinks. So to increase the solubility of CO2 in soft drinks, so these drinks are sealed under high pressure. The bottle is sealed under high pressure. So if you want to increase the amount of carbon dioxide, okay, so you better have, you increase the pressure of carbon dioxide, automatically will increase the amount of carbon dioxide in the solution, that is a soft drink. So why do you need carbon dioxide actually? What happens? So what happens is H2O plus CO2 reacts to give you H2CO3, which is a carbonic acid, and carbonic acid has a tangible taste that our tongue can detect and which accents the flavor of the beverage. Okay, so it is this carbonic acid which gives you that tangible taste. Second, more acidic means sharper. Acidic, so also the taste will be sharper. Okay. The third point, important points to notice. See now what happens when a bottle is sealed under high pressure. So it's due to high PCO2, your high amount of XCO2, that is the amount of carbon dioxide in that soft drink increases. Now when you open the bottle, what happens is you are exposed to lower pressure of carbon dioxide, so which means the amount that is soluble, the which means the soluble carbon dioxide decreases. Now if it decreases, what it has to come out, so CO2 comes out. Now what happens is as they come out, as carbon dioxide comes out, they form bubbles. This is very interesting. Okay, they form bubbles. Now bubbles bursting on tongue send shock waves through the tongue tissue, which is the source of slight but pleasurable pain. It is for this reason that soft drinks are, consumed. Okay, it is as this carbon dioxide comes out, they form a bubbles, and these bubbles burst on the tongue. They send a shock waves through the tongue tissue, which is a source of slight but pleasurable pain. That is why soft drinks, I mean, we are addicted to soft drinks. Okay, so that was the science behind why we consume soft drinks. Okay, the third application is, you know, scuba divers. See, in deep waters, what happens? There is a high pressure. So at high pressure, breathing air underwater, so increased pressure increases the solubility of atmospheric pressure. So at high pressure, what happens? So increased pressure increases the solubility atmospheric gases. Atmospheric gases in blood. Okay. So all your oxygen, nitrogen, so all the gases, because of the increased pressure underwater, what happens? So the solubility of these gases are increased. But when divers come to surface, what happens? Pressure falls, pressure decreases. So which means solubility of these gases also decreases, should decrease. Now release of the dissolved gases in blood. So this releases the dissolved gases and leads to the formation of bubbles of nitrogen. So these bubbles block the capillaries, and it creates a medical condition called as bends. Okay, which is very painful. So what is the solution? The solution is scuba divers. The tanks used by scuba divers are filled with air diluted with helium. So what is the percentage if you want to understand the percentage? So these tanks have 11.7% of helium, 32.1% of oxygen, and remaining 56% of nitrogen. So which means nitrogen has been reduced from 70% to 56%, which is good, which is okay. So too much of nitrogen causes painful bends. So the scientific name for this is narcosis, nitrogen narcosis. To reduce this nitrogen solubility, so why is helium used? So helium is not soluble in blood, not as much soluble. Helium is less soluble in blood. That is the solution. Now, since we only need oxygen, why can't we use 100% oxygen? That is also possible, right? 100% oxygen? No, 100% oxygen is called as oxygen poisoning. Okay, so this leads to confusion, impaired vision, and nausea. So that is why we don't use 100% oxygen. We use this is your ideal combination, ideal ratio of how much the oxygen should be. Okay, so Henry's law is used in, I mean, scuba divers use in their tanks. Now coming to the next application. Fourth, so at high altitudes, the pressure of oxygen is very less than the ground level. So which means low concentration of oxygen in the blood. So and tissues, which means your climbers become weak and unable to think. So this condition is called as anoxia. So that is why your oxygen cylinders, again these oxygen cylinders are not completely oxygen, but oxygen cylinders are used with greater percentage. Okay. So that was about your applications of Henry's law. So please make notes and thank you. See you all.